Recording is good. Hello, everyone. Welcome to another session on our AI Learning Club. I lost count which session is this, which is a really good sign. Today's show is going to walk us through fine-tuning. This was the seventh chapter of the AI engineering book. So Shola, feel free to take over, and then we
Yeah,
can discuss later.
thanks, Eduardo. So I'm Shola, and as Eduardo pointed, today we will be looking at chapter 7 of the AI engineering book, more specifically fine-tuning. Without further ado, can everyone see my screen, right? Okay, cool. Right. So we take it from the very top. So what is fine-tuning? Um, yeah, this is like the process of adapting a model to a specific task by further training the whole model or parts of the model. Um, in contrast to like prompt-based methods where we adapt the model by giving it instructions, context, and tools, with fine-tuning, we adapt the model by adjusting its weight. The main use is usually to improve a model's quality in terms of both general capabilities and task-specific capabilities as well. So, for example, coding or medical question engineering, answering rather. Most often, this is used to improve the model's instruction following ability, particularly to conform to a specific output style and format. So, an overview of how it works. Usually, we start with a base model that has some but not all the capabilities needed. So, the goal is to get the model to perform well enough for a specific task. We also follow the concept of transfer learning. So, what is transfer learning? It is the ability to transfer knowledge gained from one task to accelerate learning for a new related task. So this is similar to how knowing how to play the piano can make it easier to learn another instrument as well. Transfer learning improves sample efficiency, allowing a model to like learn the same behavior with fewer examples. So for example, in a scenario where we're building a speech recognition system from scratch, this might demand like thousands of hours of labeled audio data. But with fine-tuning, if we fine-tune a pre-trained model, we could achieve better results with just a few dozen hours of like domain-specific recordings. And this is especially valuable because it's usually a good solution for tasks with limited or expensive training data as well. So yes, much of what needs to be learned is usually already present in the base model. And before fine-tuning, it is recommended that there should be a definition of evaluation criteria and a design of the evaluation pipeline as well to know what it is that we are looking for, what we are aiming for, and also to help us spot issues more proactively. So types of fine tuning, there are actually quite a lot of different types of fine tuning, but I boiled it down to four main ones that stuck out in the book itself, namely self-supervised or also continued pre-training fine tuning, supervised fine tuning, preference fine tuning, and long context fine tuning. So what is self-supervised fine tuning? This is when the use of cheap task-related data is used to improve the base context before fine-tuning the model on a more expensive annotated data. So, for example, if we want to fine-tune a model to do book summarization in, say, Vietnamese, we can first fine-tune it on a large collection of Vietnamese text. So models fine-tuned only, however, it's important to note that modules fine-tuned only with self-supervised learning may struggle to provide task-specific knowledge, even if it's got like a general understanding of the world as well. And then moving on to the next one, supervised fine-tuning. This is when the model is trained using input and output pairs, where input can be an instruction and the output can be a response. And responses usually take two forms or two types of forms, open-ended or close-ended. So an example of open-ended response would be a book summarization, and a close-ended would be a classification task. Um, Again, it is important to understand the trade-off, like creating high-quality instruction data using supervised fine-tuning can be costly and challenging as well. especially for instruction that requires factual accuracy and domain expertise as well. And then moving on to the next one, preference fine-tuning. This is when human preference is maximized. This requires comparative data that typically follows a certain format, so instruction, a winning response, and a losing response as well. And then for long context fine-tuning, this is usually in regards to the context length, to extend the context length of a model. And this typically requires modifying the model's architecture, such as adjusting the positional embeddings. A long sequence means more possible positions for tokens, and positional embeddings should be able to like handle them. Again, the trade-off for this is that it's typically harder to do when we compare it to the other different techniques that we mentioned earlier on. And also the resulting model might also degrade on shorter sequences as well, which we will touch on a little bit more in the coming slides. So who can fine tune? Yeah, typically, I mean, everybody. Some, my grandma can can fine tune as well. No, but typically it falls under two categories. So the model developers and the application developers. So model developers typically post-train a model with different fine-tuning techniques before release. And even sometimes they release different model versions, each fine-tuned for specific tasks. And then application developers typically fine-tune a model that has been post-trained to fit a specific or like their use case better. The more refined a model is, and the more relevant its knowledge is to that particular task, the less work an application developer would have to do to adapt it. So, when to fine tune or like some of the use cases. Yeah, three main ones that stood out. So actually, firstly, before going into like when, it's important to note that fine tuning is an expensive operation that requires extensive resources. So things like data, the hardware, and also machine learning talent as well. Therefore, it is recommended that fine tuning should generally be attempted after extensive experiments have been made with, say, prompt-based methods. However, prompt-based methods are not necessarily a substitute for fine-tuning, and sometimes real-world problems often require both approaches as well, so they're not mutually exclusive. And then going more into the use cases, so yeah, firstly, insufficiently trained model. So if the model that we want to use was not sufficiently trained on the task we want it to do, fine-tuning it with our data can be especially useful. So for example, an out-of-the-box model that might be good or might be good at converting from text to, say, standard SQL, but it might fail with a less common or proprietary SQL language. In this case, like fine-tuning the model on data containing the type of SQL format in the proprietary system would help. And then the next one, optimizing token usage. So the more examples you add to a prompt, the more input tokens the model will use, which increases both latency and the cost as well. So instead of including examples in each prompt, we can fine-tune the model on these examples, and this would allow us to use shorter prompts with a fine-tuned model, which would then hopefully help us to decrease latency and also cost as well. It is important to note as well that in the more recent models, like there is a possibility of prompt caching. However, the number of examples cached in a prompt is still limited by the maximum context length. So with fine tuning, there's no limit to examples that can be used. So when making a decision, there are certain factors that we need to like put in place to decide whether we want to fine tune or we want to go with the approach of prompt caching. And then finally, bias mitigation. So the idea is that a base model might reinforce certain biases from its training data. So by exposing that model to like carefully curated data during fine tuning can counterbalance these biases. So for example, if a model consistently assigns CEOs with male sounding names, fine-tuning it on a data set where many female CEOs can mitigate the bias, for example. So, approaches to fine tuning. So it's typically common that like smaller models are fine tuned versus larger models. And this is because, yeah, smaller models are cheaper and also faster to use in production. And then to get the best of both worlds, there's a process known as distillation when we fine-tune a small model to imitate the behavior of a larger model using data generated by a large model. So essentially, this approach distills the larger model's knowledge into the smaller model. So we've talked about when to fine tune, and now when not to fine tune. So as I already previously mentioned, it's ideally we only want to explore, more advanced solutions like fine tuning after determining that like prompting alone is inadequate. So when not to fine tune, however, so for example, like performance degradation. When fine-tuning a model for a specific task, it can improve performance for that particular task. However, it can also degrade performance for other tasks as well. And this is most noticeable in scenarios where the model for an application is expected for use in different types of tasks. So in this case, we may want to consider using separate models for separate tasks. Also, high cost as well is something that we have to determine when deciding, whether to fine tune or not to fine tune. Fine tuning as a process requires high upfront investment. So, expensive annotated data, domain expertise, hardware, continuous monitoring and maintenance as well. So obviously using like open source data and AI generated data can mitigate the cost somewhat, but the effectiveness is not necessarily guaranteed. So again, we have to think of the trade-offs there. And then, yeah, there's an expertise that's required for like machine learning, like fine tuning. The individual responsible for that need to understand how things like an optimizer works, what learning rate to use, how much training data is needed, how to address situations like overfitting and underfitting, and how to also evaluate the models throughout the process. So that's another thing that, organizations have to question as well. Do we have the expertise to do fine tuning in the proper way? And then finally, the risk of going obsolete, as we all know, the AI space is and models as well is ever changing. Newly improved base models are being developed at a rapid pace. So if you invest a lot of time fine tuning a model, a day after a new, faster, better base model may already be released that makes the fine-tuned model obsolete for that specific task, which might render, yeah, the work and the investment that's gone into it to be a waste. So, fine-tuning versus retrieval augmented generation. The work that they do might seem somewhat similar, looking from an eagle eye perspective. So just a quick recap of what retrieval augmented generation is. It's a framework that combines information retrieval systems with LLMs to improve the accuracy and relevance of generated output. So typically when we are making a decision whether to fine tune or to use RAG, we want to determine whether this is the problem that we are encountering, if it's an information-based problem or behavioral-based problem. So if it's an information-based failure, this might mean that the model might not have the information or has outdated information. In this scenario, using RAG is ideal since its main focus is on retrieval. On the other hand, if it's a behavioral issue, fine-tuning might be the better option. So, for example, when the model's outputs are factually correct but irrelevant to the task at hand, using fine-tuning might make more sense. So some of the challenges, so like I touched on a little bit earlier on, it's quite memory intensive. So there's like memory bottlenecks due to the scale of foundation models and also backpropagation mechanism associated with neural networks training. I'm aware of time, so I'm not going to go into like the technical deep dive of what like backpropagation is, but it's worth taking a look into. And also like more trainable parameters equals higher memory footprint. So yeah, these causes some challenges, but there are some techniques like parameter efficient fine tuning that could help us mitigate some of these. So what is parameter efficient fine tuning? This is when we aim to use techniques which insert additional parameters into the model in the right places to achieve performance close to that of fine tuning, or full fine tuning rather, while using several orders of magnitude fewer trainable parameters. So, full fine tuning, for context, is when we are making the number of trainable parameters in the fine tuning process the same number of the model's parameters. So, there's a one-to-one relationship there. Whereas, like parameter efficient fine tuning allows us to, yeah, as it says on the tin, be more efficient in how we go about doing this. There are two methods to this. There's the adapter-based method and the soft prompt-based method as well. And the adapter-based method involves adding modules to the model weights, and the soft prompt-based method is allows us to like modify how the model processes the input by introducing like special like trainable tokens, which are fed into the model alongside the input tokens as well at the same time. So fine-tuning tactics, yeah, it falls under like three categories. So firstly, we always have a base starting model. Ideally, we want to have the most powerful one that we can afford. And this varies for like different projects as well. And there are different paths to this. So there's the progression path, which is like using the cheapest and fastest model to make sure that the code works as expected, and then test the data by fine-tuning and experimenting to push performance. And then the distillation path as well, which is yeah, like starting with a small or like a smaller data set and the strongest model that we can afford. And then fine-tuning the model with the small data set, then using the fine-tuned model to generate more training data, and then the new data set to train a cheaper model. It's quite a mouthful, and there's more technical details that goes with that, but I would suggest or recommend looking deeper in the book. And then the next step is like determining the fine-tuning method. So like we mentioned earlier on, we could either go the full fine-tuning route, or use a more optimized fine-tuning method such as performance efficient fine-tuning technique. And then finally, we want to determine the fine-tuning framework. So yeah, there are APIs that are provided by model providers, also cloud service providers and third parties as well. Um, and sorry, and then also we could use like a customizable fine tuning using like open source frameworks. Um, so that kind of covers all of it. And then the general takeaways from this chapter is that fine tuning is useful for improving a model's quality, both general and task specific capabilities. It follows transfer learning, which is like transferring knowledge gained from one task to accelerate learning for a new related task. We want to use it more for behavioral problems versus information-based problems. It's more efficient and economical to fine-tune smaller models versus larger models. It can be costly, both from a memory perspective, but also financially as well. And it's best to use when other techniques have been attempted and exhausted, such as prompt techniques. It's also not a catch-all solution. It can improve performance for a specific task and degrade performance for others as well. So we have to figure out if we want to use different models for different tasks. And finally, it requires fine-tuning expertise. So it might look easy from the outside, but there are details involved that needs specific expertise to be able to effectively fine-tune. And that covers it all for this chapter. And yeah, we can take questions or further discussions. Um, the floor is yours.
Thanks, Shola. This was a very heavy, I would say, chapter. It's mathematically and conceptually. I think this is the part that gets the closer to the machine learning engineer, the classic machine learning engineer process. Um, for the crowd, what's your takeaway of this chapter?
Hey, I was trying to multitask typing out a agenda item, but I'm horrible at multitasking. Um, my takeaway is it's actually a little ambiguous of when to reach for RAG versus fine tuning. I know you gave
Hmm.
the example of the model giving correct facts that are just irrelevant. Um, but I'm still a little fuzzy on what the criteria would be for determining what is relevant, because incorrect facts, I guess, inherently would be irrelevant. Can you give some more input there?
I can give an example of our documentation, GitLab documentation. For example, the model itself has knowledge of GitLab documentation, right? Because it's trained on public data and GitLab documentation is public data. But if we rely on the model to to pull the documentation, uh, it was trained, I don't know, a few months ago. So it will not pick the new documentation released on the further versions of GitLab, right? So suppose the model was trained 17.5. Now suppose that we are retraining. We are fine-tuning towards the documentation. So we have to fine-tune on every version, and that's very expensive. But fetching from RAG is a lot cheaper and more scalable. So if I want to add more resources to fetch from, that's easier. A good case for fine-tuning, though, is form like they said some examples. So for example, I really want my model to return a JSON format, and this is a notoriously hard problem to solve with prompt engineering. There are a lot of memes about it. Um, you can fine tune so that it always returns, so that it increases highly the likelihood of returning a JSON. Rag in this case doesn't really help because it's not about the facts itself, it's about the format. So I would say, for example, you want it to behave more like a code completion or more like a chat behavior of like this is what instruct models are. Instruct are models that are fine-tuned for answer and response kind of behavior. Um, so yeah, usually the answer is reg unless you have a lot of money, and that's where fine-tuning comes in. We have some issues on GitLab about exploring fine-tuning of smaller models, and we have an engineer that is working on it. Ekaterina is on the custom models team, and she's exploring fine-tuning, but it's still in early steps.
Okay, thank you.
Any,
What did
any,
you
oh, sorry, you were going to say?
what did you all learn on this chapter?
That it's really expensive.
Yeah, for me, one of the things that stood out for me is the understanding that it's not a catch-all solution. So in one instance, while you might be getting it to improve the performance for, a given task, you also have to keep an eye out on whether it's degrading performance on other types of tasks. So yeah, I thought that was it's quite intuitive, but I thought it was pretty interesting.
Yeah, what I learned is it's almost like they're playing with Lego bricks. They're trying empirically all possible ways of, I don't know, summing up different models and then trying to see what works. And a lot of deep learning has been developed like this, like the transformers architecture as well. It's trying different things until it works. And this fine tuning of, okay, let's stack layers together. Let's now sum two layers. Let's stack and go in parallel in some places. It's just like almost like a graph of sorts. It feels like there's need a machine learning algorithm to choose the best fine-tuning uh, configuration for something. I also learned what LoRa is. I heard many times what LoRa was, like I knew the name, but I never understood what the algorithm actually does of like separating a weight matrix and then do a matrix factorization on both. Um, That was interesting for me.
I'm wondering if there would be a time when it would be effective for us maybe to fine-tune model each release. Let's say we prepare a model for documentation, maybe we ship it as a WASM binary, and it's fully in browser. I'm not sure if that's a realistic thing at the moment, but maybe eventually.
Could be a fun idea to try. We could ship now the documentation, the SQLite documentation in the browser directly for RAG, but for this, it would be an interesting idea to try it out. We're exploring fine-tuning now for customers to apply style guides to code completion. So that's, like I said, a form. So you have the RAG part, which is fetching the right uh, style guide, but you have the form, like you need to transform the outputs the way that the customer wants it they look like. And that's the concept of um, adapters that they were talking about, where you attach like a block at the end of of everything that kind of transforms the outputs of everything. But it's
So in that case, you are literally affecting bias of the model in a
yes,
way.
yes.
Yeah.
You are trying to point them towards. In some ways, even prompt engineering is already trying to affect the bias to a specific direction that you want it to go. Like when you say act like a software engineer,
Right.
that's already like pointing somewhere that you want the model to go.
So for those customers that want style guides, couldn't we put that like in the context of the prompt? Like when would we try that versus fine tuning?
Uh, Both can work. For
Hmm.
these specific cases, it has like fine tuning has shown to be a little bit better at guiding the model to replicate a way of answering instead of adding. And style guides can be quite large as well, so that is a problem with style guides.
Okay.
So
Yeah. Yeah, I guess we
yeah,
learned the piece about token usage too. So if we can fine tune on the style guides, then the prompts are smaller. Right.
yeah,
Yeah.
yeah.
Okay.
You
That
do
makes
have to host the model somehow, which is
Oh,
annoying.
yeah.
So it's always a trade-off. Like it's a very difficult trade-off. Okay,
Well,
cool.
thank you.
So thank you all for joining today. Thank you very much, Shola, for preparing the presentation. This was not an easy chapter to prepare a presentation on, so I appreciate it quite a lot. Um,
Sure.
we probably won't see each other until the next year. So good end of year, everyone, and enjoy.
Merry
Thank you.
Christmas in advance. Bye.
Bye bye.